Welcome back to the third part of the elementary statistics video series here. Today we are going to be looking at the arithmetic mean, and we're going to start off by doing kind of just a simple example in SQL Server because the very next video is going to be on regression to the mean, which is a very important concept along with ceteris paribus and along with defining the population. Regression to the mean is very important. It's also one that's overlooked quite a bit. But first of all, we have to kind of discuss, well, what is the mean? Average is another name for it. So this is a measure to calculate the central tendency or essential tendency of data, though it can be heavily influenced by outliers. It is not considered a robust statistic. The calculation is the sum of observed values divided by the number of observations. And as we can see here in this simple SQL Server example, I just create a table. I insert 5 values ranging from 101 to 232. And what I do side by side here is I stack the average and the median. So we see that the average is 170 and the median is 191. And for the record, on the median, I'll have a different video on that in the future. I'm just using this as a comparison. There's a little hack. You can see that little, the common table expression that I use there for the median. Because when you have an odd number of values, you can just simply order your data, ascending and then descending, and then by using row number, and then have it to where those equal each other, and there's your median of an odd set of values. There's a lot of different ways to calculate median, but that's a fun way of doing it in the sense that you can show your work if you ever wanted to see that done. But in SQL Server, as you can see, the average is very easy to calculate. It's just the AVG function. I think that's very similar actually to Excel, so it's a built-in function. Median is one that at least later editions of SQL Server you still have to generate. I use R so much now that I don't have to do so much anymore in newer versions. Now, this is a bell curve that I got from Pixabay. This is not the skew of that data, but in this example, if we go back to here, we see that the median is 191 and the average is 170. So our median, if we were to imagine in the data set, of course, it is the midpoint. So it's straight the midpoint of the data in the sense that not the actual data values, but it is when we stack up all the values side by side, 191 is that middle value. That would be in the middle, of course, and then the mean in this case is to the left. I'm right and left blind, so I have to always think about where right and left are. But the mean is to the left of the median, right? And so one of the things that I look for, if somebody gives me, just a data set in general, I'm always looking at the minimum value first, the maximum value, and then of course the median generally, and then where the mean is relative to the median. Now that does not mean that the average or the mean, I'm using these terms, I'm intermixing them, but that does not mean the average is unimportant. What it simply means is that if it's if it can be too far to the left or too far to the right, that tells me about the tail or how far the data are spread out toward that tail, right? It could be a really fat right tail that would skew it right, but it could also be a really long out, lengthened out tail to the right. And as a case in point, when I was studying demographics, there were various patterns that I would see, like more narrow bell curves and then more kind of like stretched out bell curves in both directions. And it was really interesting. The median value of different data sets might be similar, but the max and the min, and that would be the case that I would be looking at there, would be very different. So this is something, I'll be reusing this image to kind of point around, but that's just kind of an overview of average. Now, as far as examples of when I would use average or when I wouldn't, average is very useful, like in moving averages. It's very useful in price ranges. Last year I traded cocoa futures, and I can say on a day-to-day basis, average is a very helpful measure. There would not have been any advantage using median. Or another measure in general. Narrow health ranges, like for instance, if you're tracking your average blood pressure day over day or week over week, unless you're getting really exceptional values, which would be dangerous anyway, right? Like with health values, certain things outside of, within certain ranges, I should say, like with blood pressure, if it's like too high or too low, that could be dangerous. That's not a situation where you're going to be worried about whether you're going to use the average or median. That's a situation in which you're going to be on your way to the emergency room. So those can be helpful to calculate the average and mean here. For instance, changes in weight and tracking the average weight over time will generally revolve around a strict range. It's very unlikely that you will gain 20 pounds in 3 days. It's possible, but it's unlikely. In another example, let's suppose that in the area that I'm in, I was looking at pull-ups by members of a population in an area. In the area that I'm in, the average number of pull-ups that a person could do in this population here would not exceed one, right? The median would be zero. Let's see, over 80% of people in this area cannot do a pull-up. So actually in this case, and it depends on what I would be doing, but like if I'm trying to write an attention grabbing article, I would say, in this area, over 80% of people can't do a pull up, right? I wouldn't even use the median or the mean in this case, or the average in this case. I would use, that 80th percentile, because that's going to be the attention grabber. But it depends on what I'm trying to prove. But if I were to say something like, because it's probably true, the outliers in this population would probably bump up the overall population to doing the average member to doing one pull up. And you could say that's inaccurate because technically the median is zero. And again, I can see the argument on both sides of that. So, but it depends on what I need. What am I using that for? If I'm trying to write an attention-grabbing, headline, I'm going to stick with the 80th percentile, because the fact that 80% of people in a population can't do one pull-up, that's pretty amazing. And by the way, by pull-up I mean something that's like no kipping, and you have to actually bring your chin over the bar. Now, what about when I want to return the exact midpoint or provide an overall assessment without influence from the far right or left-tailed values like income and wealth? In those cases, I'm probably going to use median or a percentile. In fact, with a lot of my clients, what I'll use is the 60th percentile. And it's because, or maybe the 80th percentile, or sometimes the 20th percentile. And the reason is because, as many of you know, there's the 80-20 rule in business. So it's not that the median or the mean is inaccurate. It's that may not be the customer base you're going after, right? You may be going after that, the 80-20 rule, right? Whether it's the bottom 80% or the top 20%. Likewise, you may be okay with looking at, let's say, the top 60% or maybe the top 40%. And so it really varies. But if I'm looking at income or wealth, it's probably going to be like median wealth or median income. And the only reason is because that tells me, okay, so 50% lower, 50% higher. And I'm looking more for something that's precise.